Do? Good morning. How's life? Vibes good? Everyone hanging out? Are there as many of you as there usually are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay. We're missing large numbers of humans. Are people sick? I'm sick. Are all of you sick?
I'm not sick.
Is the reason you're not sick is because you're the ones in class?
That would make sense.
Are the other ones sick?
Probably.
We think the other ones are sick? Okay. All right. Cool. Today we're learning about range. You kind of already know about range, but I have to teach you about range specifically because it's like confusing otherwise. Okay. Let's do some updates. So usually in a typical semester, I would have already gotten you PS1 feedback, problem set 1 feedback. Didn't happen because there's a conference at Intel this week I'm going to. So I actually don't know when I'm going to get you feedback on that, but I don't think it's a big deal if that gets delayed because it's Carol and we're not doing more Carol. So hopefully that's not too big of a problem. I looked at a pseudo-random subsample and they looked good. So I'm assuming y'all did fine on PS1 because like all the ones I looked at were good. So we'll say that's fine. Some of you have started the checkers, at least the checkerboard thing. Yes, and nominally the checkerboard part of that is hard. So if that seems hard to you, that's a consistent report. You'll have to basically think about two things at the same time on checkerboard, and you only have to think about one thing at a time on painting. So on painting, you only have to know where you are relative to the house. On checkerboard, you have to know where you are relative to the entire space and also to the last beeper. So that means that essentially you're going to have to be finding some way to store more information inside of Carol. And the way I store more information inside of Carol is by checking if a beeper is present and then moving and doing something, right? And that was the check move I showed in class. But you'll have to know when to use that or not, or you'll have to find some other solution. I wrote a diagonal solution the first time I solved checkerboard, and that was much easier to think about for me. Where when you're doing an up diagonal, you drop beepers. When you're doing a down diagonal, you don't. That's totally fine. That'll work in every grid type. Sections are ongoing, and there will be sections today and tomorrow. We're all going to our sections, right?
Yep.
And we love those sections, right?
Yeah.
That's right. So yeah, I think we're doing fine. I'm not worried about anything. I am extremely worried about GitHub Classroom, and also I'm like not really in charge of whether we use it or not, right? So like I would have stopped using it instantly on the first problem because I hate computers, right? But with the other section and potentially doing, so you're allowed to partner with people in the other section on the last assignment, so we'd have to all move off of Classroom at once. It's possible the other section wants to move off Classroom too, but can't because we're on it, right? So anyways, we're kind of stuck with GitHub Classroom for a while. One thing I did note, I think I saw 23 GitHub Classroom submissions for problem set 1, and that is really low, but I think I've talked to enough of you that makes sense. If you did not do problem set 1, and you would know if that's you, I'm extremely stressed out on your behalf, but I don't actually know if there's a single human that statement applies to, right? So I'm just going to pretend everyone did problem set 1, and I will find out, because like the way this thing always works is there's like one person that you like haven't seen for a week and you don't remember because you haven't seen them for a week. So I'll have to go track those people down. I don't think it's any of you because I've seen all of you. Today we're doing oh yes, the follow-up statement on that is, again, everyone that turned in every assignment last term got a B+. Problem set 1 is the first thing that you could plausibly not turn in, which means you can lose your B+ guarantee, right? And problem set 2 is coming up, so also turn that in. That's due on Monday. Okay, range and or not, def return. The second problem on problem set 2 is like you check to see if something's divisible by 6 or 7. Hopefully you've all looked at it. That is a little annoying without either range and or not. And specifically, it's going to ask you for two things. It's going to ask you to print a value and return a value, and I think it's non-obvious what the difference between those two things are, so we're going to teach that today. Okay, So this is range. This is the Annapurna Range of the Himalayas. These mountains are 5 miles tall, and they have nothing to do with the range we're learning about in class today. I just thought this was a pretty picture. Okay, so in Python range, you have seen range already, and you've seen range in the sort of uninteresting setting of Carol, which Carol cannot count, but for some reason Carol's allowed to know about for loops, right? So we often see range in the context of the for loop, but that's not the only place we can see it. So let's take a look at Viz Code. What was I doing? I was checking to see if numbers were even. Great use of time. Very fun. So I can just print range of 10, perhaps. And I can just run this. So range is a thing on its own. It is simply often used inside of for loops. And something interesting to look at here is that when I ask for a range 10, it actually gives me a range 0, 10. That means we can actually put a starting value inside of our range. And it's just as meaningful. This is not necessarily the most natural way to use range. We are more accustomed to using it in the statement for I in range. And we often did 10. Something we can do now, because we're not Carol, is we now have access to the print statement, so we can actually look at what is happening to I, this variable we created, and we recall variables that we usually assign variables by saying like x equals 7. This I is a different variable in that it will take on a different value each time it goes through the loop. So let's look at this. We can print I, and we can also print x, or anything else, right? When we do this, I'm going to add a little bit of text so I know what I'm looking at. I'm going to say I equals, and I can combine things I want to print with a comma, and I'm going to say x equals. Excuse me. So when I do this, we see there's sort of a special thing going on with I and with x. I and x are both variables. They're variables in the manner you would expect them to be. But the variable I is being assigned not with single equals assignment, but with this in assignment. So I is not equal to some value, but it's equal to every one of these values sort of in order. This is useful for if you have to do something 10 times, right? That variable behaves the same way everything else does. We can add I plus x. And so this I is the same type of variable anything else is. And we can see, oh, look, I can do addition, my favorite mathematical operation, right? With this I. I teased this a little bit previously, but I mentioned you can put a 0 here, and this behaves the same. And in fact, it does. But we can also use much more restricted ranges. So instead of starting at 0, I can start at 8, relatively large number. When I start at that relatively large number, I starts at that relatively large number. So this only looks at 8 and 9. Now, that should set off some alarm bells to us that I asked for I in a range from 8 to 10, and I only got 8 and 9 and not 10. So when we're dealing with a range, you get numbers from the beginning of the range to stopping before you get to the end of the range. So sort of I start counting from 8 and I stop counting before I get to 10. I stop counting when I see the 10 around the corner. Why is this? Well, not too bad. Probably, if you say I in range 5, you want something to happen 5 times. And if we start counting from 0, you have to stop at 4. Because of 0, 1, 2, 3, 4, right? So, does it make sense? Does it not make sense? I don't know. It's up to you whether it makes sense to you, right? But that's sort of the thing that's going on with range. So, we can look at and inspect ranges directly, as I've shown you. This doesn't happen that often. I want to mention one thing I'm doing here. So these triple arrows, That's from using Python in sort of what's called the Python interpreter, which I don't do that often, but if you just type Python in to your integrated terminal, it will pop up, I don't know, Python. It says Python, right? And you can type in here for I in range 5, print I. So if that's an easier way for you to try out new things, you can do things that way. It is sort of up to you how you want to try new things. Generally speaking, in this class, I'll be trying to write things in .py files and then run them, because to me this makes sense. But if you're going back and forth, you will also see this error. You will see this error at some point. There is something other than running Python that can cause this to happen. And when this happens, you turn it off and start over again. And then it will work. Okay, I'm going to demonstrate that again because I think you will see this error. Somehow, if you're ever looking at your terminal and you see the 3 greater than signs, and then you press your Run Python button, it doesn't work for some reason. And I don't know why VS Code can't figure this out. But you'll maybe get an invalid syntax. But the important thing is there'll be the 3 arrows. And if that happens, trash can, play, and it'll work the next time. Okay. So here is the same print example I used. And then here's the same sort of intermediate range example I used. Now, we can also combine the sort of for loop or the while loop or the range or anything. We can combine these things with other conditional statements. And so an obvious example is, let's look at all of the, I don't know, multiples of 5 under 60. We just have to look at something, right? So we'll look at I in range 60, because they're under 60. Or perhaps we want to look at them including 60, right? So we'll say 61. This is a for statement, so I'm going to end that line with a colon. I'm going to press enter. VS Code will auto-indent me, but I'll make sure I'm indented more than the for loop, right? Now I'm going to do a second sort of control flow statement, one of the special keywords in Python. So I'm going to say if, and I'm going to say I has a remainder. Oh my gosh, I'm not typing. I has a remainder when divided by 5 that is equal to 0. Then I will print I. And I can run this. And this will give me the multiples of 5. This might be a little confusing. That's no problem. We can do something else. We can print both I and I %5. And then we can, I'm going to use comments. I'm going to use the octothorpe to prevent this code from running. And so now I'm only going to look at I and the remainder of I when divided by 5. And there's going to be many numbers here, right? Because I'm going from 0 and stopping at 60. And what we see is that whenever we have a multiple of 5, we have a remainder of 0. Maybe a little bit more obvious with, for example, even numbers up to 10. What did I press? Did you see my sound was changing? So we can see even numbers up to 10. And we can also see multiples of 5 up to 10. And there's only going to be 2 of these, right? It may be the case that you often actually want to be starting at 1 because you don't care that 0. So maybe you want to be doing something like this. Okay. There's other things we can do. You can put different ranges inside of each other, and commonly this is done with J. We'll use smaller values. And I will print I times J equals I times J. And so we can sort of loop over these things together. It may be slightly non-obvious what's happening here, right? But This is 0 times something. That is 1 times something, so that's 1 times 4. 2 times 4, 3 times 4, 4 times 4. Okay, that's interesting. So if we just look at I and j, we'll see what's happening, which is that the outer I is slowly increasing, and the inner j is rapidly increasing multiple times. So what's going on here? This statement is running 5 times for j from 0 to 4. That's these. And then that statement that runs 4 times is itself being run 4 times for a total of 16 times. And that's what each of these sort of outer loops are. This sort of...
4 times.
Or sorry, 5, because 0 to 5.
But then why
Yeah.
did it end up with 16?
There's a bunch of zeros,
Ah.
right? And we can change that. And then you end up at 25. And this gets rid of all of the zeros pointedly, so we start at 1, right?
I see.
This sort of nested for loop, what this is called the nested for loop. This is the thing you have to learn this term. This is also like the basis of data science, right? So if you're looking at this, it may occur to you that this is a spreadsheet, right? It doesn't quite look like a spreadsheet, but under the hood, this is what a spreadsheet is, right? There's rows and columns. And in fact, the only reason I'm not printing this out as rows and columns is I don't actually have a great way to show that to you yet. But, there's things we can imagine and things we can do, right? So if I had a way to print things without a new line, I could immediately make a box with this, right? I can just print this, and that will give me exactly 25 of those. And if I could somehow, and I think there's a way to do this in Python, which is you turn off the new line at the end of a print statement, and then I print out here, this makes a box, right? So this becomes a spreadsheet quite quickly. And you can see, oh, oops, that's J. Let's see, what if we do this? You can see 1, 2, 3, 4, 5 across, and you can see 1, 2, 3, 4, 5 down, right? So these are kind of all of the things we can do with for loops. There's one last thing I should show you about the for loop. When we did this example, and I'll actually start at 1 to 61, and I said if I %5 equals 0. So if I is evenly divisible by 0, if there is no remainder when I divide I by 5, this means I is a multiple of 5 because 5 times something equals I. Okay. There's no graceful way to say that in English that I'm aware of. So I did this. I could see values from 5 to 60. I don't have to do things that way. I can also provide a step size. So we're going to go back to 0, 60, because that's a little bit easier. This is sort of printing every 5th value. And I can provide a 3rd value within the range, which is 5. And I'll see the same thing. But that's not too exciting. Why am I seeing the same thing? Well, this for loop is simply giving me every 5th number beginning at 0 and ending at 60, which is producing this result. And if we did a 2 here, we would see the same thing. If we did a 3 here, we would see the same thing. This is the way to get multiples.
What does it mean to add a 3rd number in the range?
So that's the, it's called the stride or the step size, but that's how often of each of these numbers we take that number.
Okay.
So it's giving multiples. Now, don't play yourself on this. I did 1 to 61 previously as an example. Those are not multiples of 3. Those are multiples of 3 plus 1. So what this is actually giving you, I don't know how into algebra we are. This is giving you 3x plus 1. And it's the set of all 3x plus 1 values that are less than 61, which is like, what am I doing? Typing is like dramatically harder than everything else I do. So that's like an extremely weird way to think of this, but that's actually what's going on. And we can play around with this because we can say, okay, well, what about 2 to 10, step size of 5, so that's 2x, no, that's 5x plus 2 if you're less than 10. So I think that's going to give me 2 and 7 for x of 0 and x of 1. Let's see if that's right. It's 2 and 7. So this is how much you increase by. This is where you start from. This is where you end. Why is it in that order? Because usually we only specify where we end, right? This might be non-obvious, that's fine. I essentially never see anyone use this. I'm showing it to you because you might use it on the homework. When people do use it, is not when it's multiples, but when it's negative values. This is very exciting. Every time someone is working in Python, they like to do, you know how like people like to count backwards? I don't think I made that up. Yeah, counting backwards is cool because rockets do it before they blast off, right? So we can start at 10, end before we get to 0, right? Because 0 is the before where we end place. And we can change by -1 each time. This is a good way to go backwards. When do you want to go backwards? I don't know. Go backwards if you want to, right? The thing that I find ludicrously annoying about this is if you want to start at 0, you actually have to put a -1 in that position, which I don't love. This is mostly useful if things need to go backwards for some reason, right? If you really want to impress your friends at parties, which is something I think we all want to do, everyone thinks it's really impressive when you can count backwards from 10 by 17s. I don't know why this is, but every time I've done this at parties, it really killed, right? So now you can do that much more easily than you used to. You're just hanging out with your friends and you're like, 100, and they're like, 100 what? We're like, 83. And they're like, oh, you're doing it again, right? And I'm like, 66. They're like, oh! And that's a real thing that has happened to me frequently in my life, right? So don't say I don't teach you useful things in this class. The counting backwards from 100 by 17s is like, that will get you in anywhere, right?
Okay.
Yeah.
I'll take your word for it.
Yeah, do you want to write that down? Or?
I think, yeah.
Okay, yeah. Okay. It's not on the slides, right? So, I like while loops. And I want to show you that while loops and for loops are basically the same thing. One of the things that might get you is that you're like, wow, why are there 3 numbers in range? I don't remember what all those 3 things for. The for loop in the other language also has 3 numbers in it, so for loops just have a lot of stuff in them. I think I've mentioned this before. I completed my entire undergraduate without ever writing a for loop. I just only wrote while loops because it was easier for me to think about. So I'm going to write this using a while loop. I'm going to create a value. We'll call it x because I is taken. I'm going to say x equals 100. And I'm going to write a while loop. What am I doing while? Well, okay, let's make this smaller. So while x is greater than -1. What does that mean? Well, this thing is going to stop when x is not greater than -1, so I'm going to loop while x is greater than -1. Okay? I'm going to print x, and if I just run this like that, that code's going to run forever. I know you don't believe me, so I'll show you. X is greater than -1, so it's printing x, and it's printing many times, right? It actually imprinted infinity times there. So let's go ahead and stop this. And how do we stop this? Trash can. They don't call it the trash can off, folks, right? It's the trash can. Yes, we trash can, right? Okay, so we're going to print I. No, we're going to print x. Psych, just kidding. Haha, I know what I'm doing, right? And then we're going to change the value of x. I'm going to say x equals x minus 17 because I can subtract 17 from any number I want. A lot of people don't believe this, but when I'm at parties, right? And you can also do it with 16s, which some people find more or less impressive, but usually you want to start with an odd number when you're doing 16s, right? So starting at 113 and taking 16s off of that, people go crazy for that, right? First one's 97, right? 81, right? Yeah, right? Like you see how fun this is, right? Like a lot of people like have hobbies, right? Not me.
That's
So-
a hobby.
Is it though? We should define hobby very carefully before we decide what this is. Excuse me. I'm going to throw a few prints in here so we know what's going on. Oh, I just want to have 5 new lines. I wonder if there's a way to do that. Maybe I can do I in range 5 print. Oh, cool. That did exactly what I wanted. Right. Okay. So this is my party trick, right? People always get mixed up at 49. Like no one believes 49 is 17 more than 32. People just don't believe this when you tell them. But like you do it with your hands and then you take off your shoes to count on your toes because you don't have enough fingers, right? Yeah.
Would you rather have feet for hands or hands for feet?
Yes.
Okay.
Both?
Double or nothing, baby. Right.
Well, it would be.
You have feet where your hands are.
But I think it would be like recursive, where like when I have feet for hands,
Mm-hmm.
right? So that means I have feets. And then if I had those hands for feet, I would just have 4 feet. And that would turn me into a goat. And then I would go, "Ma!" Right? So I see like a lot of upside to that personally. So it matters a lot which order you go. That's range. All right, we got a problem, folks. There's these things called Booleans. Have you all heard of Booleans before? Really?
Know somebody named Julie. Some people call her.
Where have you heard of Booleans?
I took an R class.
You took an R class last classic R programmers knowing programming already. So this is going to be a little bit easier to do in the terminal, so I'm going to type. In Python, as you know, we can print things. Well, you have to type print, right? A lot of people don't know this, but you can print some of the party trick numbers. So this is 100 minus 3 times 17. Who knows what that is?
What?
32.
No, it's 49. Yeah.
I was just guessing.
Yeah. No, it's easy, right? So it's 3 times
Minus 100 is 49,
famously.
famously.
Me and 51 go way back, right? Yeah.
Oh, yeah.
Minus 100.
Yeah, absolute banger number, right? So one of the other things we can do that we can check in Python is we can ask what type things are, right? So this is a member of the class of integers, right? So it attends integer class every day. It's just spelled int. That's because integer has too many letters, and the integers are just the whole numbers. This was more relevant when we were doing division. Do you all remember division?
Yes.
Some of you seem more convinced than others. So that thing's not a whole number, right? So we can check what type it is. That thing's a float. Why is it called a float? Because that's the name they picked in 1985. Okay. But there's this other thing, right? So previously today, oh my gosh, excuse me. I checked to see if 61% 5 equaled 0. That's false. That's just not true. I'm just telling lies, right? Do y'all ever like lie for fun? Wait,
Yes.
no. I'm a good influence.
Wait, no.
Yeah, we don't. We don't.
We don't do this.
None of us in here tell lies for fun. We only tell lies to help other people in need. Yes. And that's called acting. Okay. So I should see what the type of this thing is. And it is a bool, which is short for Boolean, right? Okay. And I know you don't believe me, so I'm going to write a script that shows the same thing. Okay, so we have print type of 10 times 2. Yeah, that's fine. And then we'll also print 10 times 2 so we know what it looks like. We're going to print the type of 10 divided by 2, and then also what 10 divided by 2 is. And then we're going to print the type of 10 equals 2, and also the value of 10 equals 2. And that is going, wow, that's full screen. That's so much screen. Okay, so I should tell you this. I want you all to know this. I have never in my life seen someone who has a job programming that does it on one screen. Like, this has never happened, right? And then we're like, hey, students, you should learn to program on your laptop you bring to class at a table sitting next to someone else that, like, you can't quite move your arms all the way because you'll accidentally start a fight, right? So if you're like, wow, my screen feels really cramped, correct, right? I can't use my brain on a screen this small, right? I just want to run wild and free through probably the quad, or what's this thing called? That's not the quad.
The North Lawn.
The North Lawn. I just want to run wild and free through the North Lawn, right? But I'm not wild, I'm tame and domesticated. So I can't do those things. Anyways, 20 is an integer because it is a whole number with no decimal point. 5.0 is a float because it is a number with a decimal point, and it is the product of a division, which might produce non-integer values. So if I throw a 7 in here, 3.5, right? And then checking to see if 10 equals 2, well, that's not really going to give me a number back, right? It's going to say either true or false. Either 10 is equal to 2 or it isn't, right? Those are Booleans. Booleans are super useful. Everyone loves Booleans. I got this friend named Julian, actually a friend of a friend, right? And I just call this person Boolean. Probably a backstory there, I don't know, right? Anyways, when you've got your friend Boolean, and you're like, I wish I had twice as many friends, right? You can just go get another Boolean, and you can combine those two friends into one friend using either and or. So let me show you an example of this, right? So I'm going to say, well, maybe I want to see if, like, x equals 10% 2 equals 1, which is checking if 10 is odd. Is 10 odd? Seems a bit odd to me. But perhaps no? Okay, right? We'll call this 10 is odd. And I'm not making fun of tennis players, so don't write in the course evals that I wrote tennis odd on the board, right? This is specifically, I didn't type the underscores, right? That's fine. I'm allowed to make fun of numbers. They're not real, right? I think you're also, like, allowed to make fun of gnomes. They're not real, right? Okay. And I think we should check to see if a number is even. And so we'll check to see, is 10 even? I can't even. Okay. And so 10 is even. 10 underscore is, no, not odd, even. Okay. That's going to be 10% 2 equals 0. Okay. And I can print these out. And we'll print out 10 is odd, and we'll print 10 is even. Oh, dang it. 10 is not odd. I was wrong. Okay. Well, I wonder if there's some way I can combine these things into an even more powerful Boolean. And I can. I can take 10 is even and 10 is odd. And I can say, oh, it is not true that both 10 is even and 10 is odd. Even and odd is mutually exclusive. I can't be both of them at the same time, which is why I can't even, because I'm odd, right? Okay. So, but what if I wanted to combine them in, like, a more friendly and accommodating way where we allow all voices to be heard, right? Well, maybe I don't necessarily need 10 to be both even and odd. Maybe it's just that one of them can be true, right? Maybe it's just that 10 is even or 10 is odd. And that is true. 10 is either odd or even. And in fact, if I check to see if 10 is even or 10 is even, I can combine them in the same way. And if I check to see if 10 is odd or 10 is odd, they're both false, right? So this is how we combine Booleans. When are we usually combining Booleans? Well, usually when you have to see if two things are true at the same time, right? When you have to see if two things are true at the same time, when you're writing programs, right? We don't have great examples of this. However, you can think implicitly. In Carol painting, there's a point at which you wanted to see if you were past the end of a house and also didn't have any more house you had to paint, right? So you were thinking about two things at the same time. There was implicitly a Boolean in how you were solving that problem. And then there's also not. We can also see, is it true that not 10 is odd? Oh, 10 is not odd. It is not the case that 10 is not even. So we can also do nots. Look out for combining these. So the not will attach to things and the and will attach to things. When is this more common? Well, let's write a loop. We'll say for I in range 10. Maybe we want to see if things are, I don't know, if their square is less than 50 and also if they're even. So, right, so square less 50. Oh, I can't even see my underscores. Look at that. That's so terrible. Okay. And that's going to be I times I less than 50. And then we'll say even is I percent 2 equals 0. And then if square less 50 and even, print I. And apparently those are even numbers that squares are less than 50. We can also do or. Everything that is true for and is also true for or, and then there's more values as well, right? So what's happening here? The square goes over 50 in between 7 and 8, because 7 squared is 49, 8 squared is 64. 9 squared is more than 50, and 9 is not even, so we don't print 9, but we print all other values. Maybe this is a little easier to see if we start at 5 and go to 15. And then we'll see we get all numbers up to 9, and then we only get even numbers after. What if we throw a not on here? Now we get all of the even numbers up to 9, and then all the numbers after 9, because we're flipping which ones are included or excluded. I promise there are use cases in real life for this stuff, right? Okay. In Python, there's a lot of things that don't look like Booleans to me that Python pretends are Booleans. And the easiest way to check to see if that's true is to write an if statement with them. So we're going to go back to typing Python. Is 1 a Boolean? No. We can check. We can say type 1. Okay, 1's an integer, so I'm sure I can't just put 1 in an if statement. What do I... Glarbu, which is the thing that I famously say. I usually don't say it like that. I usually say Glarbu, right, which is a much more fun way to say that term. Okay, apparently 1 feels an awful lot like a Boolean. That really wouldn't make sense to you unless you checked a bunch of other numbers and saw what was happening. So in fact, 0 is quite false-like in Python for some reason. It occurs to me at this point in time that I should actually just write a function that checks this, so I'm going to go ahead and write def if glarbu, which is going to accept a variable x, and it is if x is going to print glarbu. We love our glarbus, don't we, folks? Okay, so we can see if glarbu. What about point 1? Okay, that's truth-like. What about 0.0? Not truth-like. So checking the integers and floats, something to have in mind, and you can decide if you care about this or not. Basically, 0 is false. Sure. What that means is I can just check to see if 10 has a remainder like this. And I can just put that in and say, it is false that 10 divided by 2 has a remainder, which means that not 10% 2 checks to see if a number is even. That's really weird, but it is possible. And then the other thing to check is we're not doing a ton of work with strings yet, but strings that contain nothing are false, and strings that contain anything, including 0, are true. So this is quite weird that if the if glarbu of 0 is false like, but the string containing 0 is true like. My recommendation is to make sure the things you're working with are bools. Now, there is a trick you can use to turn anything into a bool, and it's just by calling bool on it. And bool is a built-in function the same way type and the same way print are. So you can always boolify something. And you can turn things back into an integer by using int, but it will not give you back the integer you started with. It will always give you 1 for true. So this is called truthiness. I hate it. Okay. These two things are equivalent. And I guess I should, well, do I want to do a demo? Well, yeah, we'll do it. Okay. You can say if not I percent 3 print I, if I percent 3 equals 0 print I. Both of these are going to check. Oh, did you see that? I tried to run my code. And there's an error. What's going on? Oh my gosh, it's the invalid syntax error, and then I see the 3 things at the bottom. What do I do? I heard something about, is it, who lives in the trash can in Sesame Street? It's Oscar the Grouch?
Yeah.
Okay, I'm Oscar the Grouch maxing, okay? Oh my gosh, it works that time. That's so weird. I wonder if I just, like, press the trash can again, will it still work? It seems like every time I push the trash can, it fixes the weird VS Code problem I don't understand. So probably if I ever don't understand anything with VS Code, I should just start looking for trash cans to click on, right? I should point out this doesn't work in real life. One time my VS Code stopped working, and I went and I found the nearest trash can in my house, and I just like bopped it on the head a couple times. That did not cause my code to work. I had to specifically hit the trash can on my computer. So it's not every trash can that works. It's only fake trash cans, right? So these two things are the same, is the moral of the story. Okay. And yeah, this is, you can put whatever in a for loop you want. I'm encouraging you to throw parentheses in things. Why is that? Maybe this seems more clear to you. I don't know, right? It can be non-obvious what not applies to. And one reason this really matters is if I put a not over here. So what's this going to do? This thing checks to see if something is divisible by 3. Not is going to look for things that aren't divisible by 3. So this should give me things that are divisible by 2 and not divisible by 3, which should be like 4 but not 6, right? So these are the multiples of 4. But if I put more parentheses in here, I can take the not, and the not will talk about this whole statement. And that gives different values. This is the things that are like, what is this? They're either divisible by 3 or 2. What's 8?
Yeah.
I don't know. I don't even know what this is doing. So anyways, look out for your parentheses, right? If you're ever not sure what's happening, start adding parentheses until it makes sense.
I'm pretty sure it's just string at the end of the word.
That makes sense. Okay, that's range. Okay. Def return matters a lot, and it matters a lot in the following way. And I'm going to give you an example. These slides, we're looking at last year's versions of the slides. Okay, so I'll disclose this to you. I thought I took out all of these this year, and I missed this slide deck. And there's another thing I put in here. These things are called type hints. I'm not going to teach you what they are. You can look them up if you want to. But I tried to remove them from all the slides because everyone complained they were confusing last year. So I'll maybe fix these slides tonight or something. But I also want to show you the difference between def and return because it's necessary for the homework, and I want you to have time to work on it. So def if glarbu is one of our favorite functions we've written in this class so far. I think we can all agree that if glarbu function, it goes extremely hard, right? Okay, so we can say if x, we print glarbu, right? And we if glarbu'd a few things. I think we if glarbu'd 0 and perhaps 1. Oh, did I spell glarbu wrong? Did I? Oh, glarbu goes in quotes because it's not a thing. Okay. Not well. Python doesn't know about glarbu. Python doesn't think glarbu's a word.
You could tell Python that glarbu is a word. You could make it a variable.
Could say glarbu
Equals glarbu. But
equals blurg. And then this is allowed. Computers are really incredible, right? Like, if you were hanging out doing with this your friends, they'd be like, what's wrong with you? But the computer can't judge you because it's incapable of critical thinking. So this is fun. This is an example of printing. But we can also do things like, hey, I wish there was a function that checked to see if things are even. Check to see if x is even, and that's pretty easy. We're just going to print, and I think what was it? It's not x percent 2, right? So we can just do some is evens down here for I in range 5. We'll do is even of I. Okay. That's true, false, true, false, true, false. This is a little bit odd to me because I'm not actually printing is even, right? So what happens if I say, oh, we'll print the value is even? That's going to print a bunch of nones. And the reason for that is that this thing is even has the value of none, which is the same thing it would have if we didn't put the print statement in here. So what's actually going on in is even is something that can be stored in a variable, same as anything else. I can say x equals is even of I, and then I can print I, or print x. I can print I in x. 0, 1, 2, 3, 4 is none. In order to have a function that returns some or that has some value, that takes on some value, I'm so used to saying return, we write the return statement here. And what this will do is instead of printing out something at the console, it will replace is even with this value. So this is going to be identical to if I do this. Oh, no, that's banned. Okay, it has to be I. So, the return statement, the usefulness of the return statement, is I can take a complicated piece of code that I don't want to think about, I can give it a name, and then I can use that name to refer to that complicated piece of code later. So, what does this mean? I only have to write an even checker or a divisible by 3 checker or a is a prime number checker once. And then I can just refer to it by name anywhere else. This is the same idea as turn left, but it's the same idea for finding values rather than just performing actions. The usefulness of this on the assignment is, I think there's something where we say like print divisible by 5 and return count. And so we look at the numbers up to x, so we say for I in range x, we're going to print X if not X percent 5. And I should test this. Oh, why is this name so long? Print. Oh, I guess because I want to know what it does. What is happening? Okay, there we go. We'll do 17. Okay. Is this not working? Wait, nothing's happening? For I in range X. Oh. These have to be I. So, I made a mistake there. X is the name, or I guess we'll call this maximum. Max. So differentiate the maximum value, I don't know, up to max. Up to. Okay. So this is the multiples of 5 up to 17. The thing the assignment asks you for is also asks you to return how many of those there are. And so how do I do that? Well, somehow I have to count up how many multiples of x there are. So I'm going to count them. I'm going to start with 0. Every time I see one, I'm going to increase my count by 1, and then I'm going to return the count at the end. Now, when I run this in the terminal, I will not see that return statement come through at all. This will appear to be identical. But what I can do is I can save that value, and then I can print that value later. And so this will give me, oh, there are 4 values that are divisible by 5 that are less than 17 and perhaps greater than 1 or something, right? So maybe we want to start at 1 here. I don't know. So what is this often used for? This is often used to return error codes from functions. This is often used to keep track of how many times something happened. Return and print have different uses. We have sort of merged them cognitively in our minds, and we need to disentangle them now. But the print statement, the purpose of the print statement is to show you, the programmer, something. And the purpose of the return statement is to show the computer something. And that's the difference. Frequently, you, the programmer, are going to want to see something eventually, but perhaps not until you specifically call print. I think that's all I have for today. I would like you to take a look at the homework, and I'm going to try and remember your names, and I have to go around in some different order to make sure I'm doing that correctly. Does anyone want to ask me any questions for the whole class before we do that? I will say, to editorialize, this content seems like not super exciting to me outside of context right now, so I'm sorry. It will get exciting basically when we get to the first project and it becomes more applied, and that will happen with the Wordle. What you might want to be thinking of right now is we're going to ask you to do the Wordle assignment at some point. That is a grid of 5 by 6 boxes. That's going to feel a lot like a for loop to us now, right? So we are conceptually getting closer to the Wordle for loop. Okay, I'm going to try and remember your names.
Your name M-I-N-A?
Yeah.
Is it an L? Okay. Check our James.
Yeah.
What's your last name?
C.
I don't know if I'll ever forget. I'm going to start. Mostly, it's more important when you get emails. Okay. Jensen. Jeff. Wait, oh, and you have a type, but I'm not letting you type that.
No.
Okay. Yes. Yeah, it says it's the sum of all the areas. Yeah, total area is correct. So they're just counting. Yeah, so that it has
Anything 100. I think 100. Oh, so it's correct in the other direction. That's it. That's very weird. That's written in JavaScript, which I think is nice. I have no idea what that code's doing.
That's so redundant.
I was like driving home from work last Friday. I was like, I'm gonna remember this. Starts with that. How do you spell that? I'll make sure that's I'm sorry. That's something. Oh no. We'll start with Benjamin. That's so much like 8 years ago. Yeah. How many letters do you have?
No, I have a section.
5.
Yeah, everything.
What's the first?
Show this.
Oh, well, yeah, okay.
I have this.
That's close enough. See, if you had more letters, I might have, I don't know.
I was kind of just.
Right in the middle.
What? For today? Like 5.
Oh, yeah. Okay. I wonder if I know your name from that.
No,
That's a good question. Yeah.
Usually you stand right there.
Yeah, that's what's happening. But I also don't remember your name. I'm pointing at you behind me. It's very awkward. Do you have 5 letters? 6. Oh no. What is one of them? We share. Corbin. Yeah. Thank you. Okay. For you, you're aging, but you're sitting somewhere different. I don't remember your name. Is it short?
Starting with
It started with K. Okay. Wait, that's the same name as Jon Snow from Game of Thrones. Maybe that'll help. I was thinking of the great ranging of like Jon Snow people. Range. Age reference now. Thank you, kid. Sorry. So your hands are much harder in this direction.
Would it be easier to stand over here?
We do these. I go and I do things some of the dark holes.
You famously have gone. Actually, no, I haven't.
Exactly. Yeah, right. So that's why I'm standing on the hard side. Just 4 letters, right?
Yeah.
Is your last initial J? Okay. I don't know letter training recipe, which is 6.
my sections are split in.
You both have to use their name. Right?
I famously do. I don't know if this one. I mean, I guess there's less. There's less.
There's actually two of them.
Yeah, no.
Yeah. All right. I have a question.
Yeah.
So you're not always supposed to return the count. My count return is not returning the count. I'm not sure why. So this is for the whole assignment. I have the count and my actual, but when I return it, I don't get anything right now. I'm not sure why. And it's just supposed to happen. Oh, I have to print, but it. Yeah.
I save the value. You could also wrap that in.
I could wrap print return this.
Nope.
Return.
No. And the reason you can't do those things really don't work because the function is only allowed to print to multiple.
this index. That makes so much more sense. Thank you.
Are you the type of person who would like to see my failure attempt, or if something doesn't work, then should I just delete it all and try again?
Yeah, just delete it all.
Because I've come up with a solution that's better than the one I just spent 30 minutes trying to do.
I guess class is over. Thank you. See you Friday?
Yeah.
Did we go late today? No, you're leaving 10 seconds early. Thief.
Time thief.
No, it's fine. It's fine. Get out. I don't want to see you anymore. If you don't want to be here, I don't want you to be here. Did everyone have fun today? Do you remember the party trick? What's the party trick? I'm thinking of a number. It's 17 less than 100. What is it?
83.
83. Okay, I'm thinking of another number. You'll never guess what it is.
83.
Oh, it's a 66. Right. We all love Ian McDiarmid, the only person that can act in the Star Wars franchise. Right. Okay. Any cinephiles? Love movies? Do you like movies? No? Okay, that's fine. Do you like books?
Yeah.
There you go. Very good. Good choice. Yes, yeah, absolutely.
I have no questions. So you told me for Carol Show. Well, I mean, I'm stuck on all of these now. But for Carol Show, once you have this.
I'm gonna show up and be like, I wrote
So
it
I'm trying to
down.
do that and it worked.
But the way I wrote it down is
Oh, you should replace them.
I was thinking about it. I'm
So you should use
if I do
create
it, here's it. So it shows that
Wait, where?
in your like go to next row.
is that
So, like,
you have
Put it after
all open intervals with
Put it here?
you read it, right?
So essentially, create checkerboard is just
I read it. I didn't internalize it.
because every time you move, you should place a beeper.
Right.
If you're going.
Then you have to start.
What I did, well, what you do is, what I do is I just go, okay, here's one
No, close enough.
set you
Let's see if this will
that has some epsilon.
Because if I took out and go to the next row and then not do anything,
that makes sense.
Is union because there's also the all the
So now-
both sets made up.
let's see what
It's not going to put a beeper there.
Open
It's using
intervals.
checkerboard.
See, it's not just that.
It's pretty trivial. Standard quality.
Yeah, that doesn't work. I don't know why, because I made a function, I made things, and it worked perfectly for like the 8x8, but then and the 8x1, but then it didn't work for any of the other ones.
So what that means is that you're assuming there is an even numbered horizontal dimension, right?
Yeah.
And so you just have to find where you were assuming that. But you don't have to assume that, right? You can always just say, go to the end of the row and stop when you hit the end of the row. Go to the next row, and then either start with a beeper or don't. And you have to know whether to start with a beeper or don't somehow.
So,
And the way to go to the next row is always it's a combination. You have to turn north, move up, and then turn away from the wall. But you can do all of those things, right?
maybe. So do I need to change the next row, or do I need to change the create checkerboard, or do I need to change all of it?
Create checkerboard is definitely fine if you're thinking of the code that way. But if it's causing you problems, you don't have to use it. I thought create checkerboard is the easiest way to solve this.
Well,
Once you have create checkerboard, the only thing you have to do is write something that covers every square.
so should I get rid of this and replace it with something different?
I think you should fix that. I think it's probably not doing what you intend.
I'm having a hard time telling what's wrong with it though. Like I know something's wrong, but I don't know what it is.
So that makes sense.
You don't have to tell me.
Well, so my impression is actually that that is the problem, right? That you have a function called next row, and I don't know that it's clear to you what you want that function to be doing and what problem it solves for you, right? So
Well, my-
next row can mean a lot of things. One of my solutions, I've done this more than once, was I go to the next row and I make sure I'm pointing the correct direction. We know yours doesn't do that because we watched it not go to the next row and point the correct direction, right?
So
But it actually just did is it turned north. This should actually probably be called turn north.
this whole function?
Yeah, well, because that's what it did, right? But I don't think that's what you want it to do. So I think it's doing something other than what you want it to do. But it is doing what you told it to do, right?
So it starts facing east. I want it to go up, turn, move, and then turn again so it can go to the next row.
How many
But-
turns do you have?
I've turned left if
That's not enough
facing
turns.
east. Yeah, because it was originally turn left, move, and then turn left. And that worked for the 8x8, but it doesn't. But then it doesn't work for like the 5x3 because it doesn't create the checkerboard.
I think it would work with the 5x3 if you're using create checkerboard instead of move.
So turn left. But then how do I get it to face the correct direction?
You probably have to ask if there's a wall on the left or something, right? So what mine does is if I'm facing east and hit a wall, I just turn left, go north, turn left. And then if I'm facing west and hit a wall, I turn right, move, turn right.
Wait,
So I check the direction, then I execute a next round.
if facing east, turn left, and then do the checkerboard up and then turn again?
No, just go to the next row. So if I'm facing east, left, move left. And that
Left.
points me in the correct direction on the next row.
That was how it was originally,
Mhm.
and you told me to replace move with create checkerboard,
Yes, which I think would have fixed it.
but it's not working.
Well, there's certainly not two turns.
So then it needs to turn again, or
So this does not say turn left, move, turn left. Right?
so do I? Okay.
I don't remember exactly what your original code looks like. To me, it seems like you've changed more than one thing at a time.
I know.
So it might make sense to go back to that code if we're working on it.
Okay. Then how do I change that code to make it work for all the other ones?
So my recommendation was to replace the moves with create checkerboards, and I think that will work.
Okay. I'll try that and I'll let you know if I have any more problems.
I think the quad's probably open today too, but I
Yeah.
wouldn't necessarily expect them to be super good at solving this either. Apparently this was hard for quad users. So, and don't spend more than 10 hours on homework this week. I think like no one gets this right ever. And I don't think it matters if it's right or not. I'll probably only check on 8x8 on a very
Okay. Well, I want to try to get it as right as I can get it.
Yeah, I think like it is worth the time if you're not busy in other classes.
Well, I am busy.
Yeah, so just have to
I was just trying to gather some wisdom and I think I'm cooked. I got the other files to work, so
That's good.
turns out like I was missing a file, or like I don't know, Jed just did his magic and it
Mhm.
worked.
That's good.
So I submitted those on time, like 2 hours before it was due.
Good job.
So yeah, the dopamine hit I got off like from submitting that and like actually like doing it was like I was so happy. But
Good job.
then now I'm looking at checker and I'm like, oh, okay. So I have to make that a checker move function.
Yeah, I like check move. What is it?
Check
It's-
move. Okay.
I call it check move. And then what is it? It's if beeper present move and then out. No, just move.
Because the beepers aren't on the map already.
Else
Right?
no.
Okay.
Move, put beeper, and then you do. You probably have a row, which is while front is clear. You check move. Check, and I think main is row. Is that right?
Def main?
Yeah, def main. Oh, it's so slow. I have no idea what this program is doing that it's this slow in Python. Python's not like the fastest, but it's pretty fast. A legal function call? Do I have to define one first?
The beeper? No.
Oh yeah, put beeper.
if I just take a photo of that real quick so I
Sure.
can
Yeah. I mean, we did this in class. It's on the slide.
Okay, perfect. We'll try to get that as possible, or as soon as possible. I was doing data science. And
Yeah.
I basically finished it, so I was thinking of like moving priorities.
In Spanish, is so much reading as well.
Yeah.
I've been just drowning in reading. That's basically all my class. It's just like read a lot of pages.
Read faster.